Welcome back to our channel mahasarkar.co.in. We are now at the end of the second lesson, that is fluid mechanics. Hardly two articles are remaining, and throughout the lesson we have learned some important characteristics of fluid. We have already learned there are two types of flow. First is called streamline flow and second is called turbulent flow. Now we have already again learned that the parameters what are used to describe the flow can be utilized only for streamline flow, as there is certain specification that we can study about the streamline flow. So again, using these streamlines, we are going to study one important term, that is called equation of continuity. So again, this will be very important article to study the fluid mechanics or the hydrodynamics. So what is equation of continuity? Before that, suppose there is a streamline flow. Like suppose this is the pipe of different cross section. As you can see easily here, the cross section of pipe is different. So opening, the end through which fluid is going to enter has broad cross section, whereas the end through which the liquid is going to escape or exit has narrow cross section. Okay, so the cross section area of that pipe is going to change. But one important term that we need to notice is that amount of mass entered in the pipe will be always equals to amount of mass that is exit or removed or taken away from the pipe. So in that case, if mass is same, the volume covered by the water or that liquid in a given time is same, then we can say one important term, that is called equation of continuity. So I will just first tell you the equation of continuity for given streamline flow. Product of area into velocity is always a constant, and this we are going to prove. Now to prove this, what we are going to consider that let A1 is the cross section of pipe at end say P. So this is end P and the cross section has value A1. So this entire cross section of pipe has what? A1. Say A2 is the cross section at end Q. So A2 is the cross section of pipe at end say Q. Okay. Now say M be the mass of fluid that enters through A1 and that get exit through what? A2. जेवढं मास एंटर होणार आहे तेवढंच काय होणार आहे, एक्झिट सुद्धा होणार आहे. But as you can see here, molecules will be more. So velocity of the that fluid which is flowing through A1 will be smaller than velocity of molecules which are flowing here at A2. Why it is happening? Crowd is more, viscosity will be more. According to Newton's law of viscosity, you are going to say that here particles will move little slower, whereas here will move little faster. So let V1 is the velocity of fluid flow at P and V2 is the velocity of fluid flow at Q. Okay. So now consider that particles of fluid from P travels to P dash in time dt. Particles of fluid from P travels to P dash in time dt. And again particles of fluid travels from Q dash to Q again in the same time dt. So time interval from P to P dash is same as what? Time interval from Q to Q dash or Q dash to Q. But in those time intervals, definitely they are not going to travel they are not going to travel same distances. Instead that they are going to travel different distances. So I will say let x1 be the distance traveled by particle of fluid from P to P dash in time dt. Okay. Similarly, I can say x2 be the distance traveled by the particles of fluid from q dash to q in time dt. Okay. They are traveling distances x1 and x2, but the time interval is same. So if I want to write the formula for velocity, then what will write for velocity? Therefore v1 can be equal to x1 upon del dt. From this I can say x1 is equals to v1 into dt. Say this is equation number 1. Similarly, I can say for v2, v2 equal to x2 upon dt is equals, then implies x2 can be equal to v2 into dt. So this is equation number 2. Now, as I said, the mass entered of the fluid from P to P dash is equals to mass entered of the fluid from Q dash to Q. So if this logic is applied there, then one can easily say that, mass of fluid through P to P dash can be equal to mass of fluid through Q dash to Q. I can write volume also. But what is the density of the fluid? If rho is density of fluid, then I can write rho equal to, what will be the formula? Rho equal to mass at P dash divided by volume at P dash, or equal to mass at Q dash Q divided by volume at Q dash Q. Okay. So I will consider this is equation number 3. So if I use mass at P dash, then it will be like, therefore equation 3 can be written as, how to write equation 3? Just write the values of mass, then in terms of density and volume I can say rho into V, say 1, capital V1 or V from P to P dash is equals to rho into V from Q dash to Q. Okay. See, this much of area and this much of distance. This much of distance is, area is what? A1, and distance is what? Area is A1 and distance is what? X1. Here area is A2 and distance is what? X2. In that case, what is the volume of cylinder? This is like cylinder, na? Volume of cylinder is like pi r square into h. Pi r square means this A and h means this x1. So I can write, instead of this and instead of this, rho is cancelled. So what we can write? Area into V1, distance is x1 equal to area into x2. What is x1 and x2 from equation 1 and 2? But from equation 1 and 2, we can say A1 into V1 dt is equals to A2 into V2 dt. See, dt get cancelled. So A1 into small v1 is equals to A2 into V2. So I can say that is product of area and velocity or speed is constant for streamline flow of fluid passing through different cross-sectional pipe. This equation, that is A into V, is constant, and this equation is called as equation of continuity. This equation is called as what? Equation of continuity. Okay, if I write this again in some different format, see how? See, A into what this? V is what? X upon T, na? So this is what? Constant, or in dt, instead of writing only T, I will write dt. So area into distance will be volume. So it is change in the volume per unit time, rate of change of volume for streamline flow of liquid is always what? Constant. So this equation is also considered as what? The equation of continuity. So these two equations are very important in the explanation of fluid mechanics, and once we consider these equations, the next articles are simple to prove. So I hope you understood this article. Thanks for watching mahasarkar.co.in. Thank you.